Hello guys, welcome to a new video. In this video I'll be talking about the collision of our galaxy Milky Way and our neighbor galaxy Andromeda. Before starting that, let's first talk about the comparison between our galaxy and Andromeda. Andromeda is the closest spiral galaxy to Milky Way. Other names of the galaxy Andromeda are Messier 31, M31 or NGC 224. Andromeda and Milky Way were made roughly at the same time at about 13.5 billion years ago. Andromeda could be called the big brother of Milky Way, as it contains over a trillion stars, about twice the most stars in Milky Way. The width of Andromeda is 220,000 light years, while our galaxy is only 100,000. Both Andromeda and Milky Way got to their current size by eating up other galaxies. Both galaxies in the past collided with many other galaxies. The current expansion of the universe caused most of the galaxies to move apart from each other, while these two galaxies are headed towards each other and they are coming close to each other at a speed of 200 km per second. But there is nothing really serious to panic now, because these two galaxies are light years apart from each other. They are about 2 million light years apart from each other. It will cause them to collide in more than 4.5 billion years. With so much time, the sun at this point will no more be a red giant, rather it will grow brighter, larger, and will be enough to roast Earth's surface. Any life form still there will be treated to some pretty spectacular cosmic choreography. After the collision of these two galaxies, the new galaxy will be termed as Milkomeda. The whole event of collision will be less dramatic than it sounds, because there will be very few physical collisions between the stars, as a matter of fact the distance between them is very large. Andromeda contains about 1 trillion stars, while Milky Way contains about 300 billion stars. The chances of even two stars colliding is very less or negligible because of the huge distance between the stars. For example, our nearest star to Sun is Proxima Centauri, which is about 4.2 light years away or 30 million solar diameters away, which is a huge distance. For visualizing the scale, let's take a Sun as a ping pong ball and Proxima Centauri as a pea, which is 1100 km away from Sun, and Milky Way is 30 million kilometers wide. Although stars are more common in the center of the galaxy, then also the average distance between each star will be 160 billion kilometers. So we can understand that in this whole event, the chances of when two stars colliding are very less and very unlikely to happen. In short, we can say that in this collision, the two galaxies will fly through each other. There will be no real physical collisions in this event. There is a really interesting chance of fact to happen, that in this collision, Milky Way and Andromeda will not be the only galaxy colliding in this event, but they could be joined by another galaxy, the third galaxy in this event, called M33 or Triangulum Galaxy, which is a companion of Andromeda. Studies suggest that Triangulum Galaxy will miss the actual collision between Andromeda and Milky Way. The galaxy will join the collision after millions of years of formation of the new galaxy. So how will the actual collision happen? As I said, the distance between two stars is very much, so it is unlikely to happen any physical collision between stars and planets. First, due to lot of empty space between the stars, these two galaxies will fly through one another, leaving gassy, starry trendles in their wakes. For eons, the pairs will continue to come together and fly apart, scrambling stars and redrawing constellations, until eventually, after a billion or so years have passed, these two galaxies will merge into a stable galaxy named Milkomeda. When two spiral galaxies collide, the hydrogen present in them is compressed, producing strong star formation, as can be seen on the interacting system like the antennae galaxies. In this case of Andromeda-Milky Way collision, it is believed that there will be little gas remaining in the disks of both galaxies, so the mentioned starburst will relatively be weak, though it still may be enough to form a quasar. After billions of years of these collisions, these two galaxies will merge into one giant elliptical galaxy named Milkomeda. but it will have a center showing less stellar density than the current elliptical galaxies. Studies also suggest that Milkomeda may also be a lenticular galaxy, depending on the remaining gases in the Andromeda and Milky Way. In the far future, roughly 150 billion years from now, the remaining galaxies of the local group will coincide into this object, that being the next evolutionary stage of the local group of galaxies. If you think this is it, you have missed the most interesting part of this collision, that is the collision of the supermassive black holes, each in the center of the two galaxies. Each galaxy, Milky Way and Andromeda, contains a central supermassive black holes. These black holes will converge near the center of the newly formed galaxies over a period that may take millions of years due to a process known as dynamic friction. As the supermassive black holes move relative to the surrounding cloud of much less massive stars, gravitational interaction led to a net transfer of orbital energy from the supermassive black holes to the stars, causing the stars to be slotted into higher radius orbits and the supermassive black holes to sink towards the galactic core. When the supermassive black holes come within 1 light year of one another, they will begin to strongly emit gravitational waves that will radiate further orbital energy until they merge completely. Gas taken up by the combined black hole could create a luminous quasar on an active galactic nucleus, releasing as much energy as 100 million supernova explosions. That means an unimaginable energy of 100 million supernova explosions will be released by the black holes. That's a really interesting probability that were represented by the 2006 simulation. These indications suggest that the Sun may come very near to the center of the combined galaxies and potentially coming close to the one of the supermassive black holes and then being ejected entirely out of the galaxy. Alternatively, the Sun might approach one of the black holes a bit closer and be torn apart by its gravity. Parts of the former Sun would be pulled into the black hole. Based on some calculation, it predicts that there is a 50% chance that the solar system in a newly formed galaxy may be swept apart 3 times further than its current position. There is also a 12% chance that the solar system will be completely ejected from the newly formed galaxy sometimes during the collision. But surprisingly, such event would have no adverse effect on the system, and the chances of any sort of disturbances to the Sun or the planets themselves may be removed. The question may be arising that then what will happen to us and our planet Earth? The answer is that Earth will have already become far too hot for liquid water to exist, ending all terrestrial life on Earth that is currently estimated to occur in about 3.75 billion years due to gradually increasing of. So the video comes to an end. If you liked our video, please comment in the comment box, share this video with your friends. I will keep entertaining you with all new videos and content. Thank you for watching.